Hey everyone, and welcome back for another deep dive. Today we're going to be looking at multi-encryption.
Ooh, very interesting.
It's a topic that's, well, it can sound pretty complex, but we're going to try and break it down, make it understandable for everyone.
Yeah, I think a lot of people hear encryption and they kind of think, "Oh, that's for the techies. That's way over my head."
Right, exactly.
But it's actually something that affects all of us,
Mm,
especially, in today's world.
absolutely, yeah. And especially as we move more and more of our lives online, right?
Yeah, for sure.
I mean, everything from our banking to, our communication to shopping.
Pretty much everything.
Pretty much everything. So it's more important than ever to understand, how our data is being protected.
Exactly.
So yeah, that's what we're going to be diving into today. We're going to be looking at what multi-encryption is, why it matters, and how it's being used, in some cutting edge technologies.
It's fascinating too because, like you said, I think a lot of people, maybe they have a basic understanding of encryption.
Right.
They know it's there, but this idea of multi-encryption,
Right.
it's like, whoa, what is that? That sounds really intense, like something out of a spy movie or something.
Right. Like some next level stuff. Like, I can lock my front door, but then how do I lock it multiple times?
Right, exactly.
So yeah, let's start with the basics then. What exactly is multi-encryption? How would you explain it to someone who, maybe doesn't have a technical background?
Yeah, so think of it like this. Instead of just having one lock on your door,
Okay.
you have a deadbolt and you have a chain lock, and maybe you even have a security system.
Right. Okay.
So you're really kind of building up these layers of protection.
Layering it on.
Exactly, and that's essentially what you're doing with data with multi-encryption. You're encrypting an already encrypted message, potentially using different methods each time.
So it's like I put my message in a locked box,
Uh-huh.
and then I put that box inside of another locked box.
Yes.
And then maybe I put that one in a vault.
Exactly. And the reason you do that is so even if one layer is compromised, the other layers protect your data.
Okay, so you're really just kind of hedging your bets, right?
Yeah, definitely. It's like that saying, don't put all your eggs in one basket,
Right.
but for digital security.
Yeah. Don't put all your encryption in one lock, right?
Exactly.
Okay, so that makes sense. And I guess, especially like you said, with the way things are changing so quickly
Right.
and the threats are becoming more and more sophisticated,
Yeah, absolutely.
it makes sense to have those extra layers of protection.
Each layer is kind of like a safeguard,
Right.
and it's making it much harder for attackers to access your information.
So are there different types of multi-encryption? I mean, or is it kind of a one-size-fits-all approach?
Well, one interesting approach is called cocktail encryption.
Cocktail encryption. That sounds fun.
I know, it's a very descriptive name.
Yeah.
It's essentially the idea of you're mixing different algorithms for each layer of encryption.
Oh, okay. So it's not just like I'm using the same type of lock
Right.
for every layer.
Exactly. Because if you think about it, if an attacker figures out how to pick one lock,
Right.
they can pick them all if they're all the same.
Okay, yeah, that makes sense.
But if you have different types of locks, it makes it much harder for them to break through all those layers.
Right. Okay. So cocktail encryption is basically using different kinds of locks, so to speak, for each layer.
Exactly. Using diverse encryption methods
Okay, I like it.
creates a more complex puzzle for anyone trying to break through.
Okay, so we've got this idea of layering encryption and even using different methods for each layer.
Mm-hmm.
But what are some like real world examples of multi-encryption in action?
Oh, for sure.
I mean, are we talking about like super secret government stuff here, or are there, everyday applications?
Actually, you're probably using multi-encryption right now without even realizing it.
Really?
Things like secure messaging apps and online banking often use multiple layers of encryption.
Oh, okay. So it's already kind of built into a lot of the things that we use.
Yeah, definitely. But one really good example of advanced multi-encryption is the Spot-on software suite.
Yeah. I was reading a bit about Spot On. It seems like you're doing some really, really interesting things with encryption.
Oh, for sure. They're definitely on the cutting edge.
Yeah.
And for instance, they use multiple layers, starting with TLS-SSL.
Yeah.
which is kind of a standard protocol for secure communication.
Right, right. TLS SSL, that's what we see when we visit secure websites, right?
Yeah,
Like the little padlock in the address bar.
exactly.
Okay, so that's already one layer of encryption. But then Spot On takes it even further.
Exactly, yeah. So on top of TLS SSL, they use permanent keys for added security. And then
Okay.
they add another layer with temporary keys that are unique to each session.
Oh, wow. So it's like a 3-lock system
Yeah, pretty much.
for your data. Wow. But what really caught my eye was this feature they call secret streams.
Yes,
It sounds like something straight out of a spy movie.
it does. It does. It's very it's a very intriguing name. And it's actually that's where things get really interesting, I think.
Okay.
It utilizes something called a zero-knowledge proof to derive keys without actually transmitting them.
Okay, hold on. Zero knowledge proof.
Oh.
That sounds pretty complex.
It is. It is.
How does that even work? And
Yeah.
why is it so important?
Essentially, it's a way to prove that you know something
Uh-huh.
without revealing the information itself.
Okay.
So it's kind of like being able to open a lock
Okay.
without having to show anyone the key.
Okay, that makes sense. But how does that apply to encryption in these secret streams?
Well, so with traditional encryption, the keys used to encrypt and decrypt data need to be exchanged,
Right.
right? And that creates a vulnerability.
Right, because if somebody's watching you exchange keys,
Exactly.
then they can make a copy and get in later.
Exactly. Exactly. But with zero-knowledge proofs, Spot On eliminates that risk
Okay.
by deriving keys without actually transmitting them.
So it's like you and a friend agree on a secret code word,
Yeah.
but you never actually say the word out loud.
That's a great analogy, yeah.
Great.
And it highlights the power of these zero-knowledge proofs.
So it's basically like you're thinking about it, but you're not actually saying it.
Yeah, in a way, yeah.
Wow. So it's like a mind meld almost.
Yeah. It's a really fascinating area of cryptography. It's evolving really quickly.
So we've got multi-encryption, we've got cocktail encryption, we've got zero knowledge proof. It sounds like a whole new vocabulary.
It is.
But before we move on to the why of all this,
Mhm.
is there anything else about the basics of multi-encryption that we should cover?
You know, it's worth noting that multi-encryption, especially using combinations of algorithms like AES and McGillies, it hasn't been extensively researched. It's a relatively new field.
Oh, okay.
So there's still a lot we don't know.
So there's a lot we don't know about how these different encryption methods actually interact with each other.
Exactly. Especially when you start layering them.
Right, right.
It gets really, really complicated.
Yeah.
And that's where things get really exciting, I think.
Yeah.
For
Well,
researchers and anyone interested in the future of digital security.
this is definitely a deep dive that's got me thinking.
Good.
But before we get too lost in the weeds here,
Yeah.
with all the technical details, I think it's important to step back and ask the big question: why should we care about multi-encryption?
That's a great question.
I mean, isn't regular encryption, like good enough?
That's a great question, and it leads us into the heart of why this is becoming so important.
All right, let's dive into the why then. I'm ready to hear what makes this so crucial in today's world.
Okay, great. So, the digital world it's constantly evolving,
Right.
right? And with that evolution come new and more sophisticated threats.
Mm-hmm.
And so traditional encryption methods,
Yeah.
while they're still valuable, they may not be enough to protect our data in the long run.
So it's like
Yeah.
relying on a bicycle lock
Right.
to protect your house, right? I mean, it might have worked in the past,
Yeah.
but as the threats get more advanced,
Yeah.
you need something a little bit stronger.
That's a good analogy, yeah. And one of the, I think, biggest threats looming on the horizon is quantum computing.
Ah, yes. The
Oh,
quantum
wow.
computer.
Yeah.
I've heard that it's going to revolutionize everything,
Mm.
but also potentially crack all of our current encryption methods wide open.
That's right.
Is that what we're talking about here?
Exactly. Yeah, quantum computers have the potential to break many of the encryption algorithms that we rely on today, like RSA, which is widely used for secure communication.
So all of our online banking, shopping, messaging,
Yeah.
all of that could be vulnerable
Potentially, yes.
once quantum computers become powerful enough.
Yeah.
That's a little bit scary.
Yeah, it's a real concern. And that's part of where multi-encryption comes in.
Okay.
Because by using multiple layers of encryption, including algorithms that are thought to be more resistant to quantum attacks,
Right.
we can create a much more robust defense.
So it's like having a backup plan.
Yeah,
For your backup plan, right? So even if one layer falls
exactly.
to these quantum code breakers, the other layers will still be there.
That's right. It's about, creating a multi-layered security system that's prepared for the challenges of the future. And that's what Spot On is doing, I think, really well.
Right.
They're taking kind of a holistic approach.
Yeah, and they're not just focused on using quantum-resistant algorithms, right? But they're also thinking about how encryption interacts with the very structure of networks.
Yes, exactly. And they've integrated this innovative concept called the Echo protocol
Okay.
into their software, which I think is just fascinating.
The Echo protocol.
The Echo protocol.
That sounds interesting.
It is, and it's essentially a way to enhance privacy and security at the network level.
So is it like sending your encrypted message into a digital echo chamber?
You could think of it that way.
Okay.
Yeah. So instead of a message following a direct path from sender to receiver, the Echo protocol kind of spreads the message throughout the network.
Wait, so it's not like traditional routing,
Right.
where a message follows a specific route.
Exactly.
It's more like it's broadcasting it everywhere.
In a way, yes.
Okay.
So each node in the network receives the message and transmits it to all its neighbors.
That sounds a bit chaotic.
It does.
How does the intended recipient actually get the message then?
Right.
If it's being sent everywhere.
That's a good question.
And wouldn't that make it easier for someone to intercept it?
Well, that's where the clever cryptography comes in.
Okay.
So these capsules that contain these messages, they're encrypted, and they don't include any sender or receiver information.
So it's like sending out a bunch of sealed envelopes with no addresses on them.
Right.
How does the postman know where to deliver them?
Right. So each node in the network tries to decrypt the message using its keys.
Okay.
And if it succeeds and the decrypted message's hash matches the hash that's included in the capsule, then it's a match.
Okay.
And the message is then displayed to the recipient.
So it's like trying different keys on a bunch of locked boxes.
Yes.
And only the person with the right key can actually open it and see what's inside.
Exactly.
Okay. I like that analogy.
And because there's no sender or receiver information attached to the message,
Right.
it's extremely difficult for anyone who's, eavesdropping on the network to figure out who is communicating with whom.
So even if somebody intercepted the message, they wouldn't know who sent it or who it's for.
Exactly.
It's like adding another layer of anonymity
Yes.
on top of the encryption.
Yeah. It makes it much harder to track communication patterns or target specific individuals for surveillance.
This Echo protocol is a fascinating concept.
It is.
But I'm curious, how does Spot On use multi-encryption in their other features? I mean, we've talked about messaging, file sharing, but are there other applications?
Yeah, absolutely. They apply multi-encryption to a wide range of their features.
Yeah.
And for example, they have a really cool email protocol called Poptastic.
Poptastic.
Yes.
That sounds like a fun name for a serious security protocol.
I know, right? It's very catchy.
Why? What does it do?
So Poptastic allows you to have encrypted chat and email using existing email servers, like the ones that use POP3 and IMAP.
So I could use my regular email account to send encrypted messages without having to set up any special software
Exactly.
or servers or anything.
Yeah, it makes encrypted communication much more accessible and user-friendly.
That's amazing.
And of course, it utilizes multi-encryption
Right.
to ensure those messages remain private and secure.
It seems like they're really committed to making really strong encryption easy for anyone to use.
Yeah, I think that's one of their main goals.
But with all this talk about complex algorithms and layered security, I'm curious, is there a downside to all this encryption?
That's a great question.
Could it ever be too much of a good thing?
That's a question that comes up a lot, and it's an important one to consider.
Yeah.
Some people argue that strong encryption can hinder law enforcement investigations
Right.
or even protect criminal activity.
Right. That's kind of the classic argument, right?
Yeah.
Against encryption.
Yeah.
But then again, privacy advocates argue that strong encryption is crucial for protecting our fundamental rights, in a digital age.
Exactly.
So it's a tough one.
It's a complex issue
Yeah.
with valid points on both sides. And I think it's important to have those open discussions about the trade-offs
So,
as encryption technologies continue to evolve.
yeah,
Yes,
absolutely.
but in the context of multi-encryption,
Yeah.
it's worth noting that layering encryption doesn't necessarily make it impenetrable.
Oh, interesting.
Right. So just because you have multiple layers
Yeah.
doesn't mean it's absolutely unbreakable.
So it's not a magic bullet.
Right.
Yeah. It's more about making it significantly harder
Yeah.
for attackers,
Yeah.
even highly skilled ones, to get their hands on your data.
That's a good way to put it. Yeah.
Okay.
It's about, raising the cost
Uh-huh.
and effort of attacking
Right.
so that it outweighs the potential benefits for the attacker.
So multi-encryption is more like building a really, really high wall
Yeah.
rather than creating like an impenetrable force field.
I like that. That's a good way to think about it.
Okay.
And just like with any security system, it's important to assess the risks and choose the level of protection that's appropriate for your needs.
This is all really fascinating stuff, but
Yeah.
I'm curious about the practical implications for people like me
Yeah.
who aren't, cryptography experts.
Yeah.
I mean, is multi-encryption something that I need to worry about in my everyday life?
I think it's becoming increasingly relevant for everyone as our lives become more digital and more interconnected.
Okay.
And while you don't need to understand all the technical details,
Right.
I think it's helpful to be aware of the concepts and why it matters.
So even if we're not, coding our own encryption algorithms or anything,
Right.
we should still be aware of how our data is being protected
Yeah,
and what steps we could take to enhance our security.
absolutely. And that's where companies like Spot On are playing a crucial role, I think,
Yeah.
because they're making these advanced encryption technologies more accessible
Right.
and user-friendly.
Okay.
So you don't have to be a cryptography expert to benefit from them.
It sounds like we're moving into a future where multi-encryption is becoming more and more important for protecting our digital lives.
I think so, yes.
But before we get too ahead of ourselves,
Yeah.
there's one more thing I'd love to explore, and that's how this all ties into the future of the internet itself.
Okay.
I mean, I keep hearing about decentralized networks and Web 3.0, and I'm curious how multi-encryption kind of fits into that vision.
That's a great question. And it leads us into a really fascinating area, I think, because we are seeing a shift
Uh-huh.
towards more decentralized online platforms and services.
Right.
And I think multi-encryption is poised to play a key role in securing those new landscapes.
Okay, I'm intrigued.
Yeah.
But to be honest, I'm still a bit fuzzy on what decentralized actually means in practice.
Okay.
Can you break it down for me?
Yeah. So think of it this way. Right now, much of the internet relies on centralized platforms and servers that are controlled by, a handful of big companies.
Right.
But with decentralization, the idea is to distribute that power and control more broadly.
So instead of having, a few big companies controlling everything,
Right.
it's more like a network of independent communities or nodes, each with their own control.
That's the general idea, yes.
Okay.
And in a decentralized network, individuals need to take more responsibility for their own security.
Okay, I'm starting to see the connection here.
Yeah.
So in a decentralized world where there's no, central authority to protect your data,
Right.
multi-encryption becomes even more crucial
Exactly.
for ensuring your privacy and security.
Yeah. It empowers individuals to control their own data and communications, even in a more, distributed and less centrally controlled network environment.
This is all starting to click for me.
Good.
It's like in a traditional kingdom, you rely on the king's army for protection.
Right.
But in a decentralized world, everyone needs to be their own knight,
Yeah.
wielding the powerful shield of multi-encryption.
I love that analogy. That's great.
Okay.
And as we move towards a more decentralized internet, I think multi-encryption could be the key to unlocking a future where individuals have more control over their digital lives.
This has been a truly, truly mind-expanding deep dive.
It has.
From the technical intricacies of multi-encryption to its real-world applications and its potential impact on the future of the internet.
Yeah.
It's clear that this is a topic that's going to become increasingly important in the years to come.
I agree.
But before we wrap up, I'd love to hear your final thoughts on what all this means for our listeners. What's the key takeaway they should walk away with?
Well, I think the key takeaway is this. Multi-encryption is not just a technical concept. It's a powerful tool for protecting our digital freedoms.
Okay.
And by understanding how it works and its potential applications, we can all play a role in building a more secure and private online future.
Beautifully said. I think that's a perfect way to sum up this deep dive. But before we say goodbye, there's one more thing I'd like to explore.
Okay.
How are companies like Spot On actually putting this vision of a decentralized, privacy-focused future into practice? What are some of the concrete steps that they're taking to make multi-encryption a reality for everyday users?
So one of the things that they're really focused on is decentralized web search.
Yep.
They've created a URL database and a web crawler called Pandemonium that allow users to search the web in a way that prioritizes privacy.
So it's like having your own personal Google,
Yeah,
but without all the data tracking and targeted advertising.
that's the idea.
Sign me up. But how does it actually work? I mean, if the search isn't happening on a centralized server,
Right.
where is it happening?
The search queries are distributed across the Spot On network,
Okay.
and then the results are returned in an encrypted format that only the user can decrypt.
Oh, it's like sending your search query out to a network of trusted friends,
Yeah.
and they each search their own little corner of the web,
Right.
and then send you back the results without actually knowing what you were looking for.
That's a great analogy.
Okay, I like it.
Yeah, it highlights the power of decentralization and multi-encryption working together to protect your privacy.
This is seriously cool stuff, but
It is.
is this something that's actually usable today?
It is.
Or is it still kind of in the early stages?
No, their platform is available right now,
Okay.
and they're constantly adding new features and improving the user experience.
Wow.
They're really committed to making these powerful tools accessible to everyone,
That's amazing.
not just, tech-savvy users.
It's encouraging to see companies like Spot On really pushing the boundaries of what's possible with encryption and privacy.
Yeah, I agree.
But speaking of pushing boundaries, I read that they're also doing some really innovative things with file sharing.
Yeah.
Can you tell me more about that?
Absolutely. Their file sharing feature called Starbeam
Okay.
is another great example of how they're combining multi-encryption with the Echo protocol to create a secure and private way to share files with friends and colleagues.
So instead of using like a traditional cloud storage service
Right.
where your files are stored on a centralized server,
Right. Yeah.
Starbeam allows you to share files directly with others without a third party having access to the data.
Exactly.
Okay.
The files are encrypted and then transmitted across the Spot On network using the Echo protocol.
Ah.
So they remain confidential and protected during
Oh.
transit.
So only the intended recipient with the correct decryption keys can actually access the files.
Exactly.
Yeah. Wow, that's impressive. It sounds like they've created this whole ecosystem of security and privacy
Yeah.
where your data is protected at every level,
Yeah.
from individual messages to file transfers to web searches.
I think that's a good way to put it.
But one thing I'm wondering about is the open source aspect of all this.
Right.
They've made their code publicly available, right?
They have, yes.
What's the thinking behind that?
Well, transparency and trust are crucial
Right.
in the world of encryption.
Okay.
And by making their code open source, Spot On allows anyone to examine their algorithms
Okay.
and security implementations to make sure there are no backdoors or hidden vulnerabilities.
So it's like having a team of independent experts constantly scrutinizing their code.
Yeah, you could think of it that way.
Okay.
Yeah, open source allows for this collaborative approach to security,
Right.
where the community can work together to identify and fix any potential weaknesses.
Yeah, it also kind of fosters trust, right?
It does.
Because users can actually see
Yeah.
how the technology works
Exactly.
and verify that it's living up to its privacy promises.
Exactly. Yeah.
It seems like Spot On is really walking the walk when it comes to their commitment to what they call democratizing encryption.
I think so.
They're not just building these tools, they're making them transparent and accessible
Right.
to everyone. That's a powerful message. This deep dive has been truly eye-opening.
Good. I'm glad.
We've covered so much ground from the basic concepts of multi-encryption to its real-world applications and its potential impact on the future of the internet.
Yes.
But as we wrap up, I'd love to get your final thoughts on what all this means for our listeners.
Okay.
What's the one key message you'd like them to take away from this deep dive?
I think the key message is this. Multi-encryption is a powerful tool for protecting your digital freedom and privacy.
Okay.
And by understanding its principles
Uh-huh.
and supporting companies and projects that are committed to ethical and transparent development,
Right.
we can all contribute to building a more secure and empowering online future.
That's a fantastic message to end on.
Thank you.
A huge thanks to you for guiding us through this fascinating and complex world. And to our listeners, we encourage you to keep exploring, keep learning, and keep questioning the digital landscape around you.
Yes.
Until next time, stay curious and stay secure.